In this lecture, we will learn about an algorithm to build a heap data structure from a given array. So our aim is to build a heap from given array, and we will see how to do it in O of n time. So our aim will be to perform that building of heap in O of n time. So we will see that. So we can use max Heapify. So max Heapify was the function that we wrote to make a heap follow the max heap property, in which the parent's value is more than both its left and right child's value. So in order to maintain the max heap property, we run max Heapify for that particular node. So now the thing is, we can use that function max Heapify in bottom up manner to convert array 1 to n. So given n elements in that array, so we can convert that array into a max heap in O of n time. So before we do that, let's have some observations. So what we see is that if given an array of n numbers and we construct a heap from it, so we will find that the elements a n by 2 plus 1, a n by 2 plus 2, a n by 2 plus 3 till a n are all leaves in the heap data structure. And the reason behind this is that we know that in a heap, that any node with index n by 2 floor, greater than n by 2 floor, will have left child and right child their indices that are greater than n. So they will not come in the heap. So all the nodes with indices greater than n by 2, floor of n by 2, will have no children, and hence they will be the leaves. So this is an important observation. So all the elements a n by 2 plus 1, a n by 2 plus 2, and so on till a n, they are all leaves in the heap. So we will see with one example also. If this is an array, so given an array and we have n is equal to 9 elements, 5, 3, 17, 10. So these are the elements, 9 elements are there. So what happens? We construct a heap. So the thing is, in a heap, a node with index I, so it has its left child index will be 2i and right child index will be 2i plus 1, and parent of I is I by 2 floor. So these are the properties. So if you want to refer to these, you can see the previous lecture of heap and heap sort. So what happens is, so we can see in this heap also, so we make 5 is in the first index, 2, 3 is its child, 17 is its right child, 10, 84. So we see that, let's see this one, 4. So node with index 4 has value 10, and its left child, which is 22, has index 8, and 9 node, this one has index 9. So these are the left and right child. So 4 into 2 is 8, and 4 into 2 plus 1 is 9. And for this one, let's say this is the node, and to find its parent, so we will do just 5 by 2 floor, which is 2. So we see that index of this node 5, parents is 2. So now the thing is, in this, if we construct heap from this array where n is equal to 9, so we say that from 9 by 2 floor, which is floor of 4.5 Okay, so this is 4. So after node with index 5, 6, 7, 8 and 9, they are all leaves, and we can see here also index node 5, 6, 7, 8, 9 are all leaves. Why? Because if 7, if it has a child, so its child will be 7 into 2, 14 and 15, but we see that okay, we have only nodes till 9. So this observation holds true. Next we see the procedure then is just what? So for the leaf it is fine, we have no children, so max heap property will be satisfied for each of these leaves. Okay, so because they have no child, so max heap, the parent is always greater than the child. Okay, so max heap property, let's just revise. So it is the value of a parent of I, okay, is greater than a of equal to a of I. Okay, so parent's value is always greater than the child value. So you can see, so now what happens? So we have to, what we have to do, and max heapify was the function that used to incorporate this property at each of the nodes we call it for. Okay, so now the thing is, these nodes are fine, I do not have to again see the max heap property for them because they are already, they have no children, so it is being followed. But for nodes which have children, so we have to go in bottom up manner. So from node 4 to 3 to 1, we have to check that each node is satisfying the max heap property. Okay, so that's what we have to do. So it's a simple algorithm. So the procedure build max heap, we run it through all the remaining nodes in the heap and run max heapify on each one. So build max heap a, so heap size is equal to length of a. Okay, and then for I is equal to length of a by 2, because this is, and floor, so this is the node which has leaves, and I is greater than equal to 1 till that, so we call the function max heapify ai. Okay, so now let's see this thing with this particular example. Okay, so what we do, so let's clean this a bit and try out. Okay, so we will try the example here. So run max heapify a comma I for I is 4, 3, 2, 1. Okay, so we will in decrement I and we will start from the first node which has children. So now let's see what happens. So what happens is we will start at this node. So we see that okay, node 4 has, so this has left child as 22, right child 9. So we see that heap max heap property, that parent's value should be greater than the child, is not satisfied. So what we do, we swap the max value of among the children and with the parent node. So what we do, so 22 we swap with 10. Okay, so 10 comes here and 22 goes there. So now this node 4 is satisfying the max heap property because that value is greater than both its children. So now we go to node 3. So at node 3 we find again 17 and it's less than 19. Okay, so what we do, so we now again max of these we replace with the swap with the parent's value. So this becomes 19 and 17 we swap. So this becomes 19, this is 17. So now again the max heap property is satisfied and we swap the parent's value with the maximum of children because that way it will satisfy the max heap property. Now what happens, node 3 is done. So we come to node 2 and again at node 2 we see that okay, value of parent is 3 and its left child and right child both are greater than 3. So we again take the maximum value of the child node and it's 84, so we swap it with 3. So this 184 and 3 we swap, so this becomes 84, this becomes 3. And in fact in this max Heapify, so if again this property was not getting satisfied here, so it would have percolated down, but as this node has no children, so it's not going down. So now let's see, we are done with node 2, we come to node 1, and here we can say that percolation will go deep down. So what happens at node 1, we see, so 5, the parent's value is less than its left child and right child both. We choose the maximum among them and swap. Okay, so 84 and 5 will be swapped, 84 and 5. So we swap them. So 84 and 5 we swap. So again, but this percolation now it has created a problem at node 2. So because 22 is greater than 5, so we again make a swap, and so it will be 22 and 5 are swapped. So 22 and 5. So now we come to node 4, and again we see that max heap property is not satisfied here, so we swap with max of the children, which is 10. So 10 and 5 get swapped here. So 10 and 5, and now because it has no children, so this is done. So we see now that okay, so now we are done for node 1 also, so it is now following the max heap property. Okay, so max heap property is getting satisfied here, and what happens is now we will look at the running time. Okay, so we understood the procedure, that what it is doing, the build max heap. So now we will try to find its running time. So one thing, as we know that okay, the max heap Heapify, which corrects the max heap property for a given node I. So this can maximum if the height is for a given node is log of n. Okay, if n nodes are there. So we see that running time simple upper bound is max Heapify cost us O of log n time. Okay, and there can be maximum of on such calls. There can, because there are maximum of n nodes, and of course there are some leaves also. So maximum it will be O of n such calls. Hence running time upper bound is O of n log n. That's correct, but it's not very accurate. We can in fact find a tighter bound. Okay, so what is that tighter bound? So that is, we see two properties. Running time of max Heapify depends upon the height of the node. Okay, so if the height of the node of that given heap is h, then the running time for max Heapify for that node is O of h. Okay, this is one important property. So if the height is small, it will take lesser time to do max Heapify. So that also we can see, if this was the node, so its height is just 1, so it will just check once and swap maximum of 1 time. This node's height is 2, so 2 times calls can be made because height is 2. So 2 swaps took place here, at maximum can take. Here the height is 3, this is 1, 2 and 3. So here 3 swaps could have taken place. 84 could have percolated here somewhere, and this could have created problems. So again swapping with its children, this node would have got problem. It would have swapped with the parent. Okay, so these 3 swaps could have occurred, so that we can say that the number of swaps is O of h. Okay, the max Heapify running time, and at most in any given height h in a heap there are at most n by 2 to the power of h plus 1 nodes are there. Okay, so if we see these two properties, so what happens? The running time becomes, so OH is the time taken for max Heapify to run for the nodes at height h plus 1, and we know that okay, the maximum height for given n nodes will be log n, and the minimum height will be 0. So for all the leaf nodes it will be h is 0, and for the root it can go up to log n floor. Okay, so we multiply these two, and sum for all the nodes. So this is n by 2 to the power of h plus 1 OH. So we can simplify it and write n and h by 2 to the power of h, and we bring the summation here. Now this summation we just try to simplify. So h is equal to 0 to infinity, h by 2h is 2. So this you can try out this mathematics. So this is a simple summation. So summation is 0 plus 1 by 2 to the power of 1 plus 2 by 2 square plus 3 by 2 cube plus 4 by 2 to the power of 4, 5 by 2 to the power of 5. If you do the summation like this, it will come out to be 2. Okay, so we will not go that deep, but it can be a arithmetico-geometric series and you can do that. Okay, so now the thing is, this is, we had the bound till log n, but I said that okay, we can take it till infinity, so it will become O of this. So O of n h to 0 to log n h by 2h will be O of n, and now we sum up till infinity. So this will be always, this is less than this, and hence now this is 2, so this will be O of 2n, which is equal to O of n. Okay, so we see that okay, the running time complexity of building a heap from a given array is O of n. Okay, so this way we see that okay, a heap data structure can be created from a given array in O of n time.